welcome back. If you've been following along this series, you know that I'm trying to get my HP 5233 Nixie counter up and running again. In part 1, I sort of went overboard on studying the schematic and operation of the counter, but at least I managed to pull all the cards and practice my animation skills. In part 2, I did a very detailed inspection of the chassis and found an errant resistor tacked onto one of the switches that gave me a little problem. To be on the safe side of things, I reformed all the caps, and while I was doing that, I took the opportunity to just admire all the cards in their discrete logic circuit beauty by matching each one up to their circuit diagrams. In the end, I gave the power supply some attention. As the transformer ohmed out correctly, I finished off with a power up and voltage check while connected to my dim bulb current limiter. Now to carry on, I think I'm just about ready to put in that A1 power supply assembly and see what results I get.
So just sticking in card A1, so I'm double confirming that's card A1. And the question is, which way does it go in? Yeah, it doesn't tell me. I don't remember which way it goes in. Oops. I'm going to have to go consult the book, because I can't remember if it goes this way or that way, and there's no numbers on the bottom. Okay, let me go check. So I went up and double checked. Components go this way. So, always good to keep your videos handy. Get in there. Okay, that's well seated. Now let's flip her over and see what we get. Voltage is taken. I'm going to let it sit here for a little while, for half an hour or so, just to let it run. It's drawing some power with the fan running, which is good. And we'll see what it looks like in an hour or so. Alright, so I put everything into a nice chart. I even ran the test for an hour on all the different pins to see what would come out. And of course, in the end, I did find in my book that there is 4 test points. 10, 18, 4, and 1. Problem is, even with a small load of a few milliamps, on 10 I'm getting 34. It's nicely regulated at 34, but I only want 20. And it only wants a plus, so 14 volts over. And it only wants half a volt. So most I could go is 20.5, so that's way too much. And the same thing on the 18. It wants negative 15 with half a volt tolerance. And I'm getting negative 20 volts, way over. 4 and 1 are okay. This one's 25, but it fluctuates depending on the line frequency. It can go up to 190. And this one is only plus 6, and it can go all the way up to 130. Plus or minus, it can go up to 130 plus or minus 10, so that one's actually fine. So it looks like, looking at my card, I'm going to have to take a closer look at this in the next project, because obviously these didn't reform, and that's probably not the right cap that's there, and everything's getting thrown out because this isn't the right cap. I think that's a... Anyway, so time to order some caps.
Much later.
The new caps came in. They all look like they're going to fit. These are 47, and that's a 10 that goes right in there. Make sure I get the polarity right when I take them out. And we'll go with my solder sucker as soon as it warms up. Usually before I take these off, I like to mark the negative end. Just a dot right there, black. Or red for the positive. That one. We'll go clean this board up. with all that ugly flux. Okay, I double checked and triple checked everything. At least I've got this, as far as my best knowledge knows, these 4 transistors are okay, as I can read diodes across them. Cleaned the board up really nice, or at least as nice as I could make it. Now to plug her in and see what goes on the power board. I've got my test results from before, so I can compare. I'm really most interested in pin 10 and 18. Okay, we're ready for the power up after changing those caps. I've got it in the dim bulb tester, just to make sure I didn't do anything totally foobarred up. Turn the power on. Nope, we got fan. That's good. So pin 10, we should have 20 volts. Pin 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one right there. No, worse, 38 volts. That's not good. How about pin 18, which is right at the end? 18. 29 volts. Even worse.
Well, at this stage, I was getting a little bit out of my depth, as the only real experience I have with voltage regulators are the LN series of ICs. Looking at the 20 volt rail, we know we have 45 volts coming in. I can get that from the table I made earlier, and about 35 volts coming out. Now that voltage drop, of course, can be accounted for by the bridge rectifier. Now I've also replaced all the electrolytic caps, and I've checked every single component on that board, and they all check okay. Therefore, the only thing that's left is this Q1 transistor, and I'm guessing if this is open, that would explain why I'm not getting any regulation. The same is probably true with the negative 15 volt rail as well. Off they come then.
So here I am with my telephoto in a bit, with my little test circuit. We should build a jig for this, and I don't have to keep rebuilding it every time I'm playing with TO3 transistors. Anyway, there's a 2N45-7A, which is a higher voltage version of this, and it's also germanium, so when I touch it, it should go off and on, off and on. Try that with the other side. You should see some leakage, very slightly on, and when you touch it, it goes off because you're grounding it out. Now let's try these. So oops, beep beep beep. Let your wires go falling down. Put that one in here. Oop, the way around there. Okay, so that's good. Goes off, goes on. Flip it around. Off, on. Okay. That one looks alright. This one? Yeah, that looks okay too. Yeah, so I don't think there's anything wrong with my transistors.
Now, being just about at my wit's end, I decided to break down and ask a simple question online. And very quickly I got some good answers back. First was to check the voltage across CR14, which is the reference voltage. And if that wasn't correct, nothing would regulate. And of course that voltage was fine. But then I got some other good advice. The topography of this particular regulator puts the regulating transistor in parallel with the load. And when you have this form of regulator, it only will regulate under a load. I did try with an LED and a power resistor, but that wasn't enough. Now what am I going to do, as I don't have an electronic dummy load?
But what I do have is a light bulb and a socket. So I'm going to set this up to use the light bulb as the dummy load in AC. Should work okay. And we're all set up to go. I've got my voltmeter on the right, on the left I should say, ammeter on the left. I got a 40 watt bulb hooked up. That's not going to draw more than a few hundred milliamps. And we'll see what we get for voltage when I start her up. Of course, across pin 10. And flip it on. 27.97 volts and 1.6 milliamp, 1.6 of an amp, 160 milliamps. So let's increase the bulb. Okay, now with a 60 watt bulb, should glow a little brighter and draw a little more current. There we go. 2.2 and 24 volts. So let's throw in a 100 watt and see what we get. Alright, now 100 watt. Throw her on. Oh, there we go. So, 19 and 32 milliamperes. So it's actually running fine. It's regulating. Now I can just start putting it back together. So I forgot to do one thing, and that was test the negative voltage. So I'm set up for that on pin 18, going out to my little test rig. There we go. Oh, spot on. Okay, so we're all set to go. Time to put the cards back in. You know, I really gonna have to make myself a current limiter slash dummy load. Really just have to change some switches around on my dummy load and my current limiter and make it into a dummy load. Well, that's another project. Before I carry on, I just make my notes on the A1 power supply board card. I replace the caps on this date, and basically 47U was found on board in place of the 10U off board. Had been recapped, evidenced by lots of flux, excess solder, blah blah blah. So I got my notes on that, and I'm not going to forget now. Now let's get the other cards and put them in. So the A5 differential amp goes in. This is the one where we cleaned the bottom off down there. It was really dirty. So A5 goes in there. Whoa! That doesn't look very healthy. It seems there's rubber stoppers there for a reason. I'll leave it in like that for now. I'm not moving this thing around. Should be okay. But at least we know why extra solder. Card seems loose. So before I get too far along, it is quite possible with these HP straight lines, oops, to put these cards in backwards, even though sometimes there's not enough room. So it's a good idea to keep the old top view and location thing in there in the correct spot so you can find out where they go. That's in there nice and tight. I'm still worried about these, they're pretty loose.
A few moments later.
You see, these cards do come in handy. These 18, the main gate, has a little standoff, and I couldn't remember which way it went. If the standoff went on the outside of the card or the inside of the card, but I made a little note for myself here. So it goes screw washer card standoff. So, come in handy all the time.
Little later.
Last card to go in, good old A26. Now I didn't swap out the electrolytics on this one yet. I wanted to see what the actual performance was with the old electrolytics in it before I changed it. Power supply I changed because I know they were probably crappy. A26. Put that in. Just careful, like. Oops. There we go. Okay, I'm going to move the camera around so we can see the Nixie tubes glow and give her to power up. Then I got to do all my notes. At least I'll have a good file on this one. It's on the dim bulb limiter, just in case something goes south, and I'm ready to throw the switch. Whoa! We have numbers. Oh, look at that. Look at that. Look at that.
And there was much rejoicing.
So to do the self-check, we put it in check. We set this to 0, that to 0. Those don't matter. I'm missing the knob there, but I know it's in frequency A. For measuring frequency, we put the time base, start at the lowest. Doesn't matter where we start. And we turn this on with the lowest time rate. Let's see what we get. Oh, 1, 2, 3, 4, 5, 10, 9, 4, 5, 6, 7. Yeah, looks like it's working. Try a different time base here. A little faster. 4 is kind of stuck there, but that's not unusual. 1. That's every 10 seconds. 2, 3, 4. There we go. It's counting. Cool.
All good HP documentation comes with an adjustment section, and I'm going to run through this next quickly. First, of course, is the power supply voltage, and there's 2 values to set, plus 20. And of course, negative 15.
Oh, so the negative is quite low at negative 11. 11. We'll be able to get up an elevator.
11. 11.
11.
Could you please repeat that?
That's down. Ah, there we go. There's up. 13. 14. 15. There we go. There we go. 15.1. Good enough for government work.
Next is the channel A and B zero adjustment. This one was a little tricky because the zero adjust potentiometers were buried deep inside the attenuator.
There we go.
Finally, there was the oscillator calibration. Now, if you want a nice detailed explanation of what I'm doing here, check out the link in the doodly-doo to Curios Marc's video, where he covers this in more detail.
Slowing down. Slowing down. Slowing down. Yeah, nice and stable. Not the best looking sine wave I've ever seen.
Now, what did concern me here in my test is I didn't get a good sine wave coming out of my oscillator. But a closer look at the manual, I see this little line where it tells me that I'm supposed to see a 3 volts peak-to-peak non-sinusoidal waveform. So no problems here.
So let's try the self check for real time now that it's all nicely calibrated. So, come to check. Sample rate minimum. There. Function selector to the desired function. Frequency. Let's start with frequency. Level A and level B to 0. Have to adjust that. Buttons looks off. Okay. Set time-based multiplier to each position. So we'll start at, it says 1 US. All zeros. Measuring frequency, okay, then it should go to 10 US. Nothing. 2.4, that's not right. 10. 100. Ugh. Way off. That should be 1,000 millicycles. 10 to 4, it should be 100 kilocycles. Something's not right here. Not working good. I'm going to have to run through these tests and see what's going on.
Much later.
So, diddling around a bit, I eventually found out what the problem was. If I go to function start, and click here, it's counting up by 1 second. However, this is way over here at 10 to the power of 7. This knob is on wrong. It should be over the other way. So let me change that knob. I must have got it off in the wrong spot, or someone put it in the wrong spot when I first started. Anyway, I'll go fix that and see what we get for the next run. After finally getting the knob on correctly, put it in the wrong position twice, it actually runs through the full test suite and it works. So 000, 0.1 of a megacycle, 1.00 microcycles, 1.000 megacycles, 1,000 kilocycles, 1,000 kilocycles, 0 kilocycles, and 0 kilocycles. And the start, 1 every 10 seconds. That's going to go off. Da 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 dun 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 dun. Beep 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 beep. There, 2. And reset. 1 second. 2, 3, 4, 5, 6. Super fast. Really fast. Infinite fast. Way too fast. And that's all working. Couldn't find anything wrong with it. I'll have to hook up the frequency generator to it next and see what happens. So let's see how this reads out on frequency. So I got 6,000. 10 seconds. I'll wait 10 seconds for that. Let's see. 600 cycles, 60, 100, 600 megacycles, 600 kilocycles, 600 kilocycles, 600 kilocycles, bouncing between 599. That's not too bad. And that's going to be a full second. Not too bad. Not too bad. So we'll go 3 megacycles. But it won't go over 3. Yep, won't go over 4 megacycles. Not bad. Not bad at all. I'm happy with that. Now all I gotta do is put it back in the box and put it on the shelf. And I got myself a nice, really Nixie counter. Cool. Well, just before I put it all back together and put it on the shelf, I figured I'd show you one blinking light. So that's the light coupled neon bulb going off and on there on A25. Of course I could go a little slower, I think. Faster. There we go. Blink, blinkety, blink.
I guess you can say I got lucky with this one, as there was really not much to repair on it. Unfortunately, I don't get to make a huge long series on repairing one of these counters. Anyway, it does tell you how well HP made these instruments back in the day. Despite it being nearly 60 years old, it even outperforms its original specifications, as it easily counts past 2 megacycles. I also see that by my checklist I'm on number 25. Enjoy! Now as my Nixie instrument takes pride of place on my instrument rack, let's let Gunny take us out as we watch that beautiful orange glow from the Nixies tick off the second.